Okay, here we go. Today's objective, I can classify and evaluate polynomials according to degree and number of terms. And everybody knows just by looking at it what concept we're still on. Is that correct? Yes. Tell your neighbor the concept that we are still on. Okay, polynomials. So we already started this one yesterday. This is the second part. We're just going to finish two more things that we need to do with the polynomials. Here we go. Yesterday I gave you guys definition for polynomials. We said that they are monomials or the sum or difference of monomials. I gave you guys examples, non-examples, and we said that polynomials are expressions only and have various terms. I gave you guys steps, and we went through the steps saying the first one was to identify, number one, identify the degree of each term. Did we do that, right? Yes. Okay. For step two, we arrange the expression from greatest to least degree, and we said that that was called standard form. And then at the end, we identify the leading coefficient. What do we say a coefficient was? The number that multiplies the variable. Are we there so far? Today, we're going to do the last two steps, classify and evaluate. Classify means naming the polynomial. What is the name of the polynomial? Okay? So, just to refresh in our memory, monomials are numbers, variables, or the product of numbers and variables that have whole number exponents if they do have an exponent. And I gave you guys one example, and we said this is not an example because it has a negative exponent. We cannot have negative exponents. To find the degree of a monomial, all we have to do is look for the variable and add the exponents of the variables. By looking at this 5, does not have a variable, therefore this is to the 0 degree. This one right here has a variable. It's got an exponent of 1. This is 1 degree. This one has variables. This is 2nd degree. And this one has a variable and it has a 4th degree. So, from there, we did some examples, remember that? Yeah. And I walked you guys through the steps and I said, identify the degree of each term of the polynomial. So let's look at this. Just a refresher, you don't need to copy it. You already have it. And you said 4 plus 3, that's 7. So this is the 7th degree. We look at this one. We look at the variables. This is the exponent of 1. Exponent of 1, what do? We add the exponent. So this is the 2nd degree. This one does not have a variable, so if we don't have any variables to get an exponent from, so this is the 0 degree. Okay? We did some more practice problems, but from there I said, let's go to setting a polynomial in standard form and then give the leading coefficient. And I said, step 1. Identify the degree of each term. So here, this one has an exponent of 1. This is the 1st degree. This one has an exponent of 5. This is the 5th degree. This is an exponent of 2. This is the 2nd degree. This one does not have a variable, so this is the 0 degree. Step 2, arrange terms from expression from greatest degree to least degree. Which is the greatest degree here? 5. So therefore, I'm going to write this one first, which is negative 7. X to the 5th, which is the next one down from there. 2. So therefore, this one is plus 4x squared. From there, which one's next? The 1. So therefore, I'm going to write plus 6x. Why did I write a plus? Because this is a positive 6. And then the last one is plus 9. Once we arrange it from greatest to least degree, that one is called standard form. Remember that? Okay. And the last thing, we needed to identify the leading coefficient. I said go to the first term from left to right. Here's my first term. And look at the coefficient. What number is multiplying the variable? Leading coefficient is negative 7. we're done with that. Today, we're going to finish the last two steps, classifying polynomials, which means naming them. Okay? So here we go. All right. So everybody has this table in front of you. And I put this table because it's easier to follow. This table helps us get organized with the names of polynomials. This top is going to be the degrees. Now check this out. So if a polynomial has only a 0 degree, let's say that's the highest degree it has, it's known as a constant. If the polynomial has the highest degree being 1, then it's a linear. If the polynomial has a highest degree of 2, then it's a quadratic. If it's a third degree, the highest, it's a cubic. A fourth degree, it's a quartic. A fifth degree is a quintic. And from there, it's known as 6th degree, 7th degree, 8th degree, 23rd degree. So whatever the degree, you just say that number and the degree. Are we there? So that's classifying according to degree. But over here, I have classifying according to the number of terms. We said if the polynomial has 1 term, it's known as a monomial. Remember that? 2 terms, it's a binomial. 3 terms, a trinomial. And at the end, 4 or more, it's a polynomial, because poly means many. So far, so good? Now check this out. So I put this together so that you can follow and find out the name of the polynomial. We always start by naming it the degree first, and then from there we go to the term, the number of terms. So check this out. Don't write anything down, just pay attention. Eyes up here, here it goes. What if I had x plus 5? First things first, we need to identify the degrees of that polynomial. How many degrees in this term right here? And this term? 0. So 1 and 0. What's the highest degree? 1. So therefore, I circle here, and then lets me know that it's a linear. Are we there so far? So that's according to degree. Now, I'm going to check how many terms does this polynomial have. Here's 1. Here's 2. Therefore, 2 terms, then therefore it's a binomial. So if I was to write this one where it belongs here, linear, and binomial, I write it here. So therefore, this polynomial is known as the linear binomial. Let me repeat that again. This polynomial is known as a linear binomial. Everybody see that? Yeah. Okay. I'm going to stop there so you guys can help me fill out the table. Give me a second. On your table, I want you to write this where it belongs, just as you see it here illustrated, so that you know that it's called a what? A linear binomial. Copy that, please. Don't write it here. I'm going to be writing mine here so that you place them where they belong. Are we there? Okay. Do that, please. Okay, so let's continue. I'm going to go ahead and reset this, and I'm going to give you another one, and let's do this next one together. Here it goes. You don't have to copy this, but after you see the degree and the number of terms, I want you to place it where it belongs. Here it goes. X squared plus 4x plus 3. Don't say it out loud. Think about it. Okay. So first things first, I'm going to label my degrees. This one is 2 degrees. This one is 1, and this one is, what's the highest degree? 2. So I circle the 2 because I know it's going to go there, or at least you label it so that you know. From there, I look at the number of terms. Let's see, 1, 2, 3 terms. So therefore, this is a trinomial. So let's place it, where does it go? Right here, x squared plus 4x plus 3. So what is the name of this polynomial? It's a quadratic trinomial. Everybody see how that works? Okay, fill that in, please. Here goes another one. I want you to do this one by yourself. Here goes. 2x to the second, y to the third, plus 4x. Okay, see where that goes? Okay, here we go. So, first of all, we need to identify the degree. This term right here is the 5th degree because it's 2 plus 3. Is that correct? Yes. This one is to the 1st degree. So the highest degree for this polynomial is 5. Right now, we know it's a quintic. How many terms? 1, 2, so therefore it's a binomial, and it goes here. 2x squared y cubed plus 4x. This polynomial is called quintic binomial. What is it called? Quintic binomial. Okay, once again, to clarify, we do not add the degrees. We just write the degree so that we know which one is the highest. Which is the highest of the two? A 5. That's why it's known as a quintic. 2 terms, it's a binomial. Okay? So, I'm going to give you a couple more, and I want you to place these, please. Okay, here we go. Place that one. Okay, here we go. 23. Does it have a variable? No. So this is to the 0 degree. Only one term, therefore it goes here, and it's a constant monomial. All right, so any questions with this? So now, I'm going to go ahead and take off the table. I'm going to give you a couple more so that you can do, but you're only going to see the polynomials. Here we go. I just need you to place them where they belong. Ready? Yeah. Okay, here they go. Put them on the table. Here we have 5n cubed plus 4n, negative 2x. I want you to place each one on the table so that you know the name of it. That's what we are doing. That's why we're doing what? Classifying. That's what it means to classify. We're giving it a name. So, with a show of hands, this one, who said that this is a cubic binomial? Yeah. That is correct. And for this one, who said it's a, for this one, it's a linear monomial? That is correct. And the last thing that I want to cover, check this out. So, we're going to try and find the root of a polynomial. This is a lot of fancy words. A root of a polynomial is, in one variable, is a value of the variable for which the polynomial is equal to 0. Right. So now, check this out. Let me interpret what that says. What they're saying is that they're going to give us a polynomial such as this one that we have here. Now, according to what we know now, we know the name of this polynomial. The highest degree of this polynomial is 2, so it's a quadratic. And it's 2 terms, so it's a binomial. So, what we want to find out is the number that they give us a root? How do we know that? Check this out. This is what we do. I take the polynomial, 3x squared minus 48. And what I'm going to do, I'm going to substitute that value where we have a variable. So that becomes, check this out, 3 times 4 to the second degree minus 48. So what is 4 squared? 16 times 3 minus 48. What is 3 times 16? 48 minus 48. What is 48 minus 48? If at the end, with that number that they give us, if we get a simplification of 0, then 4 is a root of 3x squared minus 48. Everybody with me? Yes. So, with that said, I want you to do this number. Write down the polynomial 3x squared minus 48, substitute 0, please. Yeah, you can continue there. Just the polynomial. Copy the polynomial and substitute that number and see if that's a root. You should have done 3x squared minus 48. 3 times 0 squared minus 48. 3 times 0 minus 48. This is 0 minus 48. So therefore, what's left? Negative 48. So since this is not 0, then 0 is not a root. If it is 0 at the end, it is a root. If it's not, then it's not. Okay, homework. Make sure you work on pages 465 through 466, numbers 21 to 77 odds, and also bring me the signed progress on Monday. Have a good weekend, guys. Enjoy your homework. See you guys on Monday.